Good morning. Yesterday and the day before, we were looking at Gauss elimination. The first lesson, we just used Gauss elimination to solve a system of linear equations. And then yesterday we used it to solve, well, not to solve, to work out the rank and the basis of a given augmented matrix. So we'll look at a few more examples of how we do that. That is solving a system using Gauss elimination, and then also working out the rank and the basis of a matrix. So these are all questions from your textbook, exercise 6.1. So we start number 1. We have square root of 5x plus square root of 2y. This is equal to the square root of 2, and then square root of 2x plus square root of 5y. This is equal to the square root of 5. So we have to solve this by using Gauss elimination. The first thing we need to do is work out or write down the augmented matrix. So the augmented matrix looks like this: square root of 5, square root of 2, square root of 2, square root of 5, and then on this side we have our variable, our solutions, or the constants. So remember, the aim is to make this 1, 0, 0, 1 here, and then from there we can read what x is and what y is. So from here, the first thing we can do to make this one here a 1 is divide the whole row by square root of 5. So I'll divide this first row by square root of 5, and then I do the same thing with the second one. So I want to make this a 1, then it's easier to subtract the 2 rather than trying to find some constant to multiply one of the rows or both of the rows by, so I can subtract to get 0. So this one, divide by square root of 2, and then this gives me 1, and then square root of 2 over 5, square root of 2 over 5, and this is 1, square root of 5 over 2, square root of 5 over 2. So now I want to make this a 0, so I can just say row 2 minus row 1. Then from there I have 1, square root of 2 over 5, square root of 2 over 5, and this is 0. Then I have square root of 5 over 2 minus square root of 2 over 5. So that you can do on your calculator, where square root of 5 over 2 minus square root 2 over 5. Okay, so this is 3 over the square root of 10. And then the same thing over here, square root of 5 over 2 minus square root of 2 over 5. This is also 3 over the square root of 10. So you can see with this row here, I can divide throughout by the square root of 3, not square root of 3, just 3 over the square root of 10. Okay, then I'll get 0, 1, 1, and then from there, if I have a 1 here, I just multiply it by square root of 2 over 5 and then subtract so that I can make a 0 over here. So what I have is 1 square root of 2 over 5, then square root of 2 over 5. This is 0, 1, 0, and then this one here we say row 1 minus square root of 2 over 5 multiplied by row 2. So this is 1 minus 0 is just 1, then square root of 2 over 5 minus square root of 2 over 5, that is 0. And then the same thing over here, I will get 0. Then for the second row, nothing has changed, and this is what I have. So from here, I can see that x plus 0 is equal to 0. So this means that x is equal to 0. And then 0 plus y is equal to 1, which means that y is equal to 1. So with a system with only 2 variables, very easy. Substitute them back over here. So you can see if this is 0 and this is 1, its square root of 2 is equal to square root of 2. And then 0 here, 1, square root of 5 is equal to square root of 5. So my x and y are correct. So looking at this, even though it's not part of this specific question, we can work out what the rank is, what the basis is, and general solution, basic solution. So we said the rank is just the number of unique unit column matrices. So you can see this is 1 because there's a 1 here and zeros everywhere else. And then this is another one, and they're not the same because the one here is at the top of the column, the one here is at the bottom of the column. So my rank here is 2. Then my bases, both of these variables, x and y, form the bases. And after this, what we would do for the general solution is let the non-basic variables equal to a, b, or c, some number, but here there are no non-basic variables. So all our variables are in the bases. So our solution, we just have a solution instead of a general solution. A solution, we write it like this. We have x, y, the transpose here, this is equal to 0, 1, and the transpose over there. Okay, so you can see x is 0, y is 1. Okay, that was number 1, part 1. And okay, number 2. This is still under number 1. So we have x plus 3y plus 3z. This is equal to minus 2. And then x plus 3y plus 4z. This is equal to minus 2. X plus 4y plus 3z. This is equal to minus 3. So we want to solve this system using Gauss elimination. So we draw our augmented matrix. We have 1, 1, 1, 3, 3, 4, 3, 4, 3, and then minus 2, minus 2, minus 3. That is our augmented matrix. And again, the aim is to have the identity matrix over here, and then you can just read what your x, y, and z are. So very easy to make these ones here 0, because for the second row, I just say row 2 minus row 1, and then for the third one, I say row 3 minus row 1. Then this gives me 1, 3, 3. The first row has not changed. Then for the second one, 1 minus 1 is 0. 3 minus 3 is 0. 4 minus 3 is 1. And then minus 2 minus 2, that is 0. And same thing here, 1 minus 1 is 0. 4 minus 3 is 1. 3 minus 3, this is 0. Minus 2 minus negative 2, this is minus 1. Then I will interchange row 2 and 3. So that means I just swap them. This row here will come over there, and then this row here will come over there. Then I want to make this one here a 0. So I will say row 1 minus 3 times row 2. So I'm working that out before I swap them. So I say 3 minus 1 times 3. Then I swap the 2 rows. So what I have is 1 minus 0, and then this is a 2, and then 3 minus 0 is 3, then 3 minus 3, this is 0, then minus 2 minus 0 is just minus 2. Then now I swap row 2 and 3, so I have 0, 1, 0, minus 1, then 0, 0, 1, 0. Okay, so I need to make this one here 0. To do that, I just say row 1 minus 3 times row 2. Okay. Okay, so this will give us 1 minus 0 is 1, 3 minus 3, this is 0, 0 minus 0 is 0, and then minus 2 minus negative 3, this is 1, and the other rows remain the same. And from here we can see that x is equal to 1, y is equal to minus 1, and z is equal to 0. Okay, then again the second part, it's not asked in this specific question, but it's good to practice. We can see that we have 3 unique unit matrices, unit column matrices. So there's this one here, there's a 1 in the first place, zeros everywhere else. This one has a 1 in the second place, and there's a 0 on top and a 0 below. This one has a 1 in the third place, and there are 2 zeros above. So each of these are different. So we can say that the rank here is 3, and then our basis is each of the variables that represent the columns. So there's x, y, and z. So our basis is x, y, and z. And then with the general solution, remember the general solution comes in when you have non-basic variables. So you have some variables here that are not part of the basis, but here all our variables form part of our basis, so we don't have a general solution, we just have the solution itself. So we can say that the solution x, y, z, this is equal to 1, -1, and 0. So notice with this one, there is no commas between the elements because this is a matrix. This is a set, and then this is a matrix. Question 2. Part 3. So I'll call this 2.3. Oh, no, we did this one already. See, 2.4. We have x1 plus 2, x2 plus x3 minus 3, x4 is equal to 1, and we are supposed to work out the rank, the basis, and the general solution. So we do the same thing, we write down our augmented matrix. So this is 1, 2, 1 minus 3, and then here I have 1. So we already have a 1 here, and this is unique, and this one here is the same as that one, so there is only one variable that will form part of our basis. So we can start by saying the rank is equal to 1, and then the basis here, because you can make any of these numbers 1. So this one and that one are already 1. If I wanted to, I could divide everything by 2, then this one here will be 1. Or I could divide everything by -3, then this one here will be 1. So you can see that the 1 can be at any of these 4 places. So the basis that you pick, it doesn't matter which variable you pick. So here I will pick the first one, so my basis is x1, but x2 is also a basis, x3 and x4, they're equally the same. So here, this is a basis, it's not the basis, it's not the only one. Okay, so if this one is my basis, then the non-basic variables, so non-basic variables just mean the variables that are not part of your basis. So I have my variables x1, x2, x3, and x4. x2, x3, and x4 are not in the basis, so they form part of my non-basic variables. Then x4. Oh, my pen is not working anymore. Alright, this should be x4. Okay, the order I list them in doesn't actually matter. Right, so when we want a general solution, to get a general solution, what we do is our non-basic variables, we equate them to constants. So we can say let x2 equal to a, where a is any real number, x3 is equal to b, which is again any real number, and then x4 is equal to c, which is any real number. And then we write the basic variable in terms of the non-basic variables. So if we look at that, I have x1 plus 2x2 plus x3 minus 3, x4 is equal to 1. So that means I have x1 plus 2a plus b minus 3c. This is equal to 1, and therefore x1 is equal to 1 minus 2a minus b plus 3c. And then I can write this down for the general solution as a matrix. The first term will be 1 plus 2a minus b plus 3c. Then x2 is a, x3 is b, and x4 is c. So transpose, and this is equal to your x1, x2, x3, x4 transpose. So that's the general solution. And then the basic solution. So remember, basic solution, that just means that your non-basic variables a, b, and c, you equate them to 0. So you say a, b, and c are all equal to 0. Then you have 1, 0, 0, 0. This is equal to x1, x2, x3, x4. Then there's a transpose at the top over there. Okay, so you also could have picked x2 as your basis. So maybe you'll, or here x3. So here maybe you'd have 1, 0, 0, 1, 0, like that for your basic solution. But the way you would do it is exactly the same. Then look at one more, number 5. x1 plus x2 minus 2x3 plus x4 plus 3x5. This is equal to 1, 2x1 minus x2 plus 2x3 plus 2x4 plus 6x5. This is equal to 2. Then we have 3x1 plus 2x2 minus 4x3 minus 3x4 minus 9x5. This is equal to 3. So we want to work out the rank and the basis of this system here. So as usual, the first thing we need is our augmented matrix. So the augmented matrix will look like this. I have 1, 1, minus 2, 1, 3. And I have 1 here. 2, minus 1, 2, 2, 6, 2, 3, 2, minus 4, minus 3, minus 9, 3. Okay, so we can start by making these two zeros. So to do that, I say row 2 minus 2 times row 1. And then this one here, I say row 3 minus 3 has not changed, so it's 1, 1, minus 2, 1, 3, and 1. Then here I will have 0, then minus 1, minus 2 is minus 3, 2 minus negative 4 is 6, 2 minus 2 is 0, and 6 minus 6 is 0, and then 2 minus 2 is 0. And the same thing over here, I have 3 minus 3, which is 0. Then 2 minus 3 is minus 1. Minus 4 minus negative 6, this is 2. Then 3 minus 3 is minus 6, and then minus 9 minus 9, this is minus 18, and is 0. Okay, so I can get a 0 over here. I just say 3 times row 3 minus row 2. Then the first row has not changed, and then this row here I can afterwards divide it by negative 3. So 1, 1, minus 2, 1, 3, and 1. The second row I divided by minus 3, so I have 0, 1, minus 2, then 0, 0, 0. Then the next row here I have 0, then minus 1 times 3 is minus 3 minus negative 3, that is 0. Then 6 minus 6, this is 0. Then I have negative 6 times 3 is minus 18 minus 0, just minus 18. And then here, minus 18 times 3 is minus 54. Minus 54 times minus 0 is minus 54. And then here, 0 minus 0 is 0. And then this row here I can divide by minus 18. So I have 1, 1, 1, minus 2, 1, 3. I have 0, 1, minus 2, 0, 0, 0, and then 0, 0, 0, 1, 3, and 0. Okay, so now we want the rank. So rank, okay, I see we can also make this one here 0 by subtracting this. So here, let's say row 2, row 1 minus row 2. So that's 1 minus 0, 1 minus 1, minus 2 minus 2, then 1 minus 0, 3 minus 0, and then 1 minus 0, and then we have 0, 1, minus 2, 0, 0, 0, 0, 0, 0, 1, 3, 0. Okay, we can also make this one here 0. Just say row 1 minus row 3. So I have 1, 0, 0, 0, 0, 1, then 0, 1, minus 2, 0, 0, 0, 0, 0, 0, 1, 3, 0. Okay, so now we have column matrices. So you can see there's a 1 here, zeros everywhere else, 1 here, zeros. This one here, we could make this one a 1 by dividing the whole row by minus 2 if we wanted that one to be part of the basis. And then here, this is a unit column matrix, and this 3 here, we can make it a 1 if we wanted to by dividing the whole row by 3 if we wanted that one to be part of our basis. But the way that it is, we can see that the unit column matrices that we have this one here, we have that one here. So you can see that these two are essentially the same, because if I make this one 1 by dividing everything by 2, then this one is no longer a 1. So I have to pick either x2 or x3, depending on what you want. But since this one is already a 1, I don't want to use that one. And the next one is this one here. And again, this one and that one are the same. They cannot both be in the basis because the position of the ones are the same. And if I made this one a 1, this number here will become 1/3. Okay, so from there I can say the rank of my matrix. So the rank is equal to 3. Then the basis, there are several options. The first one is x1, x2, and then x4. You could also rewrite, like I said, make this one a 1, and then this one will change to -1/2. So you might also get something like x1, and then instead of x2 we have x3, and then keep x4, and then x1, x3, and then here instead of x4 you make this one here a 1, you get x5. But for your basis, I just need one answer. So pick any one of these. That is your answer. So we will pick this first one here. That is a basis. So remember, the basis is not necessarily unique. You might have several of them, but the number in the basis is always the same. So it's not possible to have one basis that has 4, another one with 2, and another one with 1. They will all have the same number. So that is our basis. We picked x1, x2, x4, and then our non-basic variables. Maybe let's not. I want to pick the one that is in the book, so that you can check that the answer is the same, but it doesn't actually matter. So if we pick this one as our basis, or the one that they picked, here we have x1, x2, x3, and x5. Then our non-basic variables. These are just the variables that are not in our basis. So since we pick x1, x3, x5, the ones that are not in the basis are x2 and x4. So we have x2 and x4. Then to get the general solution, what we do is we let general solution. we let x2 equal to a, where a is some real number, and then x4 is equal to b, where b is some real number. And then we rewrite the basic variables in terms of the non-basic variables, so using the equations that we have here. So you can see from here I have x1 is equal to 1, so that one does not even depend on a and b. x1 is equal to 1. Then from the second one I have x2 minus 2x3 is equal to 0. So I have x1 minus 2x3 is equal to 0. So this will mean x1 minus 2a is equal to 0. Sorry, not x1. It's x2 and x3. So this would mean that x2 is equal to 2a. What am I doing? I'm substituting them incorrectly. x2 is the one that is a. So I have a minus 2x3 is equal to 0. So this means that x3 is equal to a over 2. And then from the next equation, I have x4 plus 3x5 is equal to 0. So that's x4 plus 3x5. This is equal to 0. So this means that b plus 3x5 is equal to 0. This means x5 is equal to negative b over 3. So then we write down our general solution like this. We have x1, x2, x3, x4, and x5. Remember, with the general solution, there are no commas to separate them. So this is equal to x1 is just 1. x2, we say it is a. x3, we worked it out, we got a over 2. x4, we say it is b. And then x5 is minus b over 3. So that is our general solution. And then for the basic solution, so with the basic solution, remember that a and b, we make them 0. So we will have 1, a is 0, so this is 0. Again, 0 divided by 2, 0. B is 0, and then negative 0 divided by 3 is just 0. So this is our basic solution. So general solution in terms of A, B, C, and so on. Basic solution, all those letters A, B, C, and whatnot, you make them 0, and then you get your general solution. Okay, then number 8. X plus y plus z is equal to 0. 6x plus 4y plus 4z is equal to 0. And then y plus 2z is equal to 0. So we have to work this out. We want the rank, the basis, and let me see, this is what I wanted to show. Okay, I think number 6 is better. So I want to illustrate something here with number 6. Number 6, we have 2x1 plus x2 plus 5x3 plus x4. This is equal to 5. Then we have x1 plus x2 minus 3, x3 minus 4, x4. This is equal to minus 1. And then we have 3x1 plus 6x2 minus 2x3 plus x4. This is equal to 8. And then 2x1 plus 2x2, 2x3 minus 3x4. This is equal to 2. Okay, so we need the augmented matrix. We have 2, 1, 5, 1, 5, and 1, 1, minus 3, minus 4, minus 1, 3, 6, minus 2, 1, 8, 2, 2, 2, minus 3, 2. So here we can say row 1 minus row 4 minus 2 times row 4. Row 1 minus let's see, we have 1 minus that minus 2 times row, and then I have row 3 minus 3 times row 2, then row 4 minus 2 times row 2. Okay, that is what I have. And then after I do that, I am going to interchange row 1 and row 2. But let's work it out anyway and see. We say 2 minus 4. This is 2. Why did I do that? I shouldn't multiply by 2, just row 2 like that. So it's 2 minus 2, this is 0. 1 minus 2 is minus 1. 5 minus 2 is 3. 1 minus negative 3 is 4. And then I have 5 minus 2, which is 3. Then the second row does not change. Then row 3, we said 3 minus 3 times that, this is 0. 6 minus 3 is 3. Minus 2 minus negative 9, that's 7. And then 1 minus negative 12, which is 13. Then 8 minus negative 3, which is 11. Then the last row we will get 0, 0, 8, 5, and 4. So this row minus 2 times that one. So 0, 0, 4 minus, 2 minus negative 6, 3 minus negative 8, 2 minus negative 2. Okay, then we say we want to interchange row 2 and 3. So we're going to interchange row 1 and row 2. And then this row here, we will divide it by negative 1. And then yeah, let's do that. Now we have 1, 1, minus 3, minus 4, and then minus 1, then 0, 1, minus 3, minus 4, minus 3. Then 0, 3, 7, 13, 11, 0, 8, 5, 0, 0, 8, 5, and 4 here. Okay. Then with row 3, I can say row 3 minus 3 times row 2 is 1, 1, minus 3, minus 4, minus 1, 0, 1, minus 3, minus 4, minus 3. Then this one, 0 minus 0 is just 0. 3 minus 3 is 0. 7 minus negative 3 is 2. And, oh no, that's not right. So this is 7 minus negative 9. This is 16. Then 13 minus negative 12. This gives us 25. And then 11 minus negative 9, which gives us 20. And then our last row, we just keep it like that, 0, 0, 8, 5, 4. Okay, so here, what can we do? We can say row 3 minus 2 times row 4. Then we end up with 1, 1, minus 3, minus 4, minus 1, 0, 1, minus 3, minus 4, minus 3, then 0, 0, 0, because it's 16 minus 16, 25 minus 10 is 15. And then 20 minus 8 is 12. Then our last row does not change. Then here we have a 5 and then 4. So this row will divide it by 15, and then the last one we will divide it by 8, and here we can also say row 2 minus row 1. Row 1 minus row 2. So for the first one, when we say row 1 minus row 2, we'll have 1, 0, 0, 0, and then 1 minus negative 3 is 2. So we have 1, 0, 0, 0, and then 2. Then with the row 2, we say we're not going to change anything, so it's just 0, 1, minus 3, minus 4, minus 3. Then the third row we divide by 15, so it's 0, 0, 0, 1, and then 12 over 15 is 4 over 5. And then the last one, we said we divide by 8, so we have 0, 0, 1, 5 over 8, then a half over here. Okay, so we can make this one 0, so that this is also a unique one. And to do that, we just say row 2 plus 3 times row 4. So we have 1, 0, 0, 0, then 2 here, then 0 here, then 1 minus 0 is 1, minus 3 plus 3 is 0, then minus 4 plus 3 times this, we get negative 17 over 8, and then minus 3 plus 3 over 2 is minus 3 over 2. And then the other rows remain as they are, 0, 0, 0, 1. We have 4 over 5. The last one, 0, 0, 1, 5 over 3. Or 5 over 8. And this is the half here. Whew. Okay, then where else can we make a 0? Then we can make zeros here and there. Okay, so or let me I don't want to write too much. So we can make this one here as 0. And to do that, we just say row 2 plus 17/8 times row 3. And to make a 0 here, we just say row 4 minus 5. This is 5/8 times row 3. Then work this out. 1 0 0 0, and then this is 2. Then this will be 0 1 0 0 1/5. Then I have 0 0 0 1. One. Sorry, that's not right. This is 4/5. Then I have 0 1 0 0. Okay, so this is what I have. So here we can see that our rank is 4, but sometimes you get equations like this at the end. So you can see here I have 0 0 1 0 and then 0 here. So from this is obvious that x3 is equal to 0, because this, from this equation here, we can see that x3 is equal to 0. Okay, maybe this was not the best example to illustrate this, because all of them, there's a unique solution here anyway. But it's possible that you don't have a unique solution, but one of the variables is obviously 0, in that you have a 1 somewhere in the row, and then on the other side there we have 0 here. But this one here, we can still say that the rank is equal to 4, the basis. So I can still interchange these last 2 rows so that it's in the nice way that we like. The basis is x1, x2, x3, and then x4. And then you can write down the unique solution: 2, 1/5, 4/5, and 0. Okay, so we'll stop here for today and continue tomorrow.